Hello everyone, welcome to MG Academy. The next topic in data structure is Huffman coding, also called as Huffman algorithm. Huffman coding is a data compression technique. What is Huffman coding? It is a data compression technique in which the size of data is reduced or the size of message is reduced. Okay. See, if you want to store a file in your computer and the size of that file is big, then what do? You perform compression, and after compression the amount of time required to store that file will be less, isn't it? Similarly, if you want to send a message from sender to receiver like ABC, now if this message is compressed, then the number of bits required to send this message will be less. Number of bits required will be less if this is compressed, right? So this is nothing but compression, and through Huffman coding we can achieve this. Next, in Huffman coding, the data is inputted as sequence of character. The data is inputted as sequence of character. See, like this. In this way, the data is inputted as sequence of character. And from that, a table of frequency is created. From this sequence, what will create? Will create table of frequency. Now see how table of frequency is created. See. Your character and your frequency. See, in this sequence you can see there are three types of characters. A, B and C, right? So we'll write here A, B and C. So these three characters are there in this sequence. Now frequency. How will calculate frequency? So frequency is dependent upon the number of times that character has occurred in the sequence. So occurrence of character in the sequence, on that the frequency is dependent. See, here in this sequence A has occurred 3 times, right? So frequency of A is 3. B has occurred 3 times in this sequence. So frequency is 3. And C has occurred 2 times. So frequency is 2. Now like this, a table of frequency is created. From table of frequency, Huffman tree is constructed. So from this tree, what will construct? Will construct Huffman tree. Okay, from this table, from table of frequency, Huffman tree is constructed. Okay. Then encoding of each character is done. And then after construction of Huffman tree is done, encoding of each character is done. Here there are 3 types of characters. So encoding of all these 3 characters will be done, and that encoding will be binary encoding. Okay. Now consider this example. So a table of frequency is given to you and you have to construct Huffman tree from this table. Okay. So in first step what we'll do, we'll arrange these characters in increasing order of their frequencies. Okay. So step 1. Like this, we'll arrange these characters in increasing order of their frequencies. Okay. C frequency 5, D with frequency 7, E with frequency 9 and F with frequency 30. Okay, like this we have to arrange. Now the next step is to select two characters from these which have least frequency. Among these all, we have to select 2 characters which have least frequencies. So those are A and B. See, A has 2 and B has 3. So these 2 have least frequency among all, right? So we'll take this 2. What we'll do, we'll merge these 2. We'll merge 2 and 3 and we'll create a parent node like this. 2 plus 3 is 5, right? So now 5 is the parent of these 2, right? So we'll cut this 2 because we are done with it. Remaining we'll take it down like this. C5, D7, E9, F13. Okay. Now from this 5 we have to select. Now we'll not consider this 2 and 3. We'll consider this 5. 5 then C5, D7, E9 and F13. Okay, so out of this 5 we have to take 2 characters which have least frequency. So here you can see this 5 and these 2 have least frequency. So again what we'll do, we merge both of them. So 5 plus 5 is 10. So 10 will get here. 5 C5. This 5 is formed by A and B. A2, B3. Okay. Now again we'll take this down. This remaining 3, D, E and F will take it down. Okay. D7, E9, F13. Okay, like this. Now again out of these 4 we have to select 2 characters with least frequency. So here D and E have least frequency. So we'll merge these 2. So 7 plus 9 is 16. So we'll get 16 as the parent node. Okay. So here I'll write 16 and it is formed by D7 and E9. Okay. And this 10 will be as it is. So 10, it is formed by 5, and here F13, it will be as it is. Okay. Now again out of these 3 we have to select 2 characters with least frequency. So 10 and 13 have the least. So we'll merge them. So 10 plus 13 is 23. Okay. So here 23, 10 and this will be as it is, this subtree. Okay. And this 16. So we'll merge these 2 because only 2 are remaining. Okay, so we'll merge these 2. So 23 and 16 together 39. Okay, so this will be our final Huffman tree. Now always remember, out of these 2, 16 has minimum frequency. So the character with minimum frequency will be on the left hand side and the character with greater than this will be on the right hand side. Okay. Here 16 has minimum frequency, so it will be on the left, and 23 has greater frequency, so it will be on the right. Okay. 16 as it is, D7, E9, 23, okay. So this is our final Huffman tree. Now the next step. Now the next step is to assign 0 and 1 to this Huffman tree. Okay. So 0 will be assigned on the left side and 1 will be assigned on the right side. Okay. So left of 39 is 16. So here 0. To its left is 7. So 0. Right of 39 is 23. So here 1. Right of 23 is 13. So 1. Left of 23 is 10. So 0. Left of 10 is 5. So 0. Left of 5 is 2. So 0. Left of 10 is 5. So 0. So it is to the right. So it's 1. Okay. So right of 5 is 3. So here also 1. Similarly, right of 16 is 9. So 1. So in this way we'll assign 0 and 1 to this Huffman tree. And after assigning this, what we'll do, we'll find the Huffman coding for each character. Right. So I'll create one table here. I'll write code and everything in that table. character, frequency and code. Frequency of A is 2, B is 3, C is 5, D is 7, E is 9, F is 13. Now we'll find the code for each characters. So for finding code of A, here there is A. So what we'll do, we'll traverse this tree. So we'll traverse it from root to the leaf, that is A. So you can see each character is the leaf node. So we'll traverse the tree from root to the leaf. So here we have to find a code for A. So we'll traverse the tree from 39 to A. Okay. So what we can see here, there is 1 0 0 0, right? So the code for A is 1 0 0 0. Similarly B, here it is 1 0 0 1. Okay, so 1 0 0 1. Then C, 1 0 1 1 0 1. D, 0 0. E, 0 1. F, 1 1. Okay, so these are the codes for the respective characters, right? Now by looking at this table, we can make two observations. The first observation is that, see, every character is having different codes, right? Variable code. See, A has code 100, which is having length 4, right? C is having code 101 and its length is 3. E is having code 01 and its length is 2. F is having code 11, its length is 2. So like this, every character is having different code, that is variable code, and the length are also variable. So we can say it is variable length encoding. Variable length encoding, right? Now the second observation which you can make is that, see, F is having frequency 13, which is the highest among all. F is having frequency 13, which is highest among all, and its code is 11, which is of length 2. Code length 2, right? A has frequency 2 and its code is 1000, which is of length 4. Code length 4, right? So from this you can conclude that the character which have highest frequency has code length small, and the character which has least frequency has code length big. So these are the two observations which we can make from this table. And also Huffman coding follows the technique of prefix code. Prefix code. So now let us see what is this prefix code. Okay. Now let us understand what is this prefix code. And Huffman coding ensures this prefix code. Also it is called as prefix rule. Okay, and what does prefix code says, or what does prefix rule says? No code is prefix of another code. What does this rule says? No code is prefix of another code. Now let us understand this with the help of an example. Very simple example I'll take. See, suppose we have three characters A, B and C, and their codes are 0, 1, 0, 1. Okay, these are the characters and these are its codes. Okay, and now one message is sent from sender to receiver, and that message is 0, 0, 1. It is encoded. Okay, and what the receiver will do? The receiver will decode this message. When this message will be received by the receiver will decode this message. Now there will be ambiguity while decoding this message, because this single message will be decoded into two ways. See how. The first way is, now see, the first, there is 0, first bit is 0. The character with code 0 is A. So for first bit, what does the receiver will decode? A. Next bit again 0. The character with code 0 is A. And then third one is 1. And the character with code 1 is B. So, this is one solution. Now another solution. First bit 0. Code of A is 0. So 0. Then together 0, 1. The character with code 01 is C. So here there will be C, right? So this is another way. Now you can see that the sender is sending only one message and the receiver is decoding into two ways. So this is nothing but ambiguity, right? Now how the receiver will know which is correct, isn't it? Now, how this ambiguity arises? Why this ambiguity is there? Because this 0, this code of A, that is 0, is a prefix for this code, isn't it? C. Code of C is 0, 1, and here alone this 0. Alone this 0 is code for A, isn't it? So we can call this 0 as prefix, right? We can call this 0 as prefix. C. Code of C is 0, 1. And this 0 alone is code for A, isn't it? So we can call this 0 as prefix, right? That is, code of A is a prefix for this code. So this should not happen. No code should be prefix of another code. And only when this condition is satisfied, there will be no ambiguity. And Huffman coding ensures this condition. This prefix code condition, or you can also call this as prefix rule. Right? So Huffman coding ensures this prefix rule or prefix code, and so there will be no ambiguity while decoding at receiver. You can also check our previous example. No code you will find as prefix of another code. Okay? And that's it for today. Hope you understood my today's lecture, and if so, then give this video a big thumbs up, subscribe to my channel and share it with your friends.